Hello again. Today I am going to be critiquing this video time-lapse of The Sun Proves Flat Earth. I'm going to go ahead and let this guy give a standard introduction.
The Earth. Is it really just a big ball floating in space, spinning on its axis at 1,000 miles per hour, hurtling around the sun at 67,000 miles per hour, whizzing through the Milky Way at a milk-curdling speed of over 500,000 miles per hour, and warp driving through the heaven at over 500,000,000 miles per hour? And
Okay. So this video is not primarily about the motion or not motion of our Earth. But the underlying question of this speed that we're talking about is, why don't I feel like I'm tearing through the skies at a terrific speed? But of course, if you think about it, it's obvious. Have you ever been in an airplane? Here's the uh, here's the cruise speed of a Boeing 737. It's 490 knots or 564 miles per hour. And yet, when you look out the window, do you see things tearing by at a horrible speed? No, instead you see, well, typically, fairly distant objects lazily floating by. And do you feel wind tearing at your face and hair? No, because the plane is a fairly closed system. The air just comes right along with you. And if you lay down, maybe, and close your eyes, maybe you could even sleep. Because cruising at a set speed is very much like standing still. Now, the plane is not perfect. You may feel some turbulence. You may hear the engines. You may feel the engines to some degree. But on Earth, where it's not actively pushing itself through the heavens, there are no sounds accompanying the motion and no turbulence of space. So again, the answer is sitting there right in front of you. On an Earth passively responding to the balanced forces, you wouldn't feel a darn thing, and a thoughtful person wouldn't expect to feel anything. Okay, at this part, the video is going to try to explain the tilt of the sun as it goes through the sky. What it's referring to is if the sun rises over here, it will tilt as it reaches its highest point to the left. And then it'll come back to the right and set like this. He talks about that back here a ways. Let's let him talk about it.
it's sweeping. The sun over flat Earth is doing a big circle, right? Look at this thing. See it sweeping to the right? It's like a lefty bowler. Just toss that down the alley, and there it goes, hooking into the pocket.
Okay, I think it's fitting that he made that sound because in order for the sun to get that low on a flat earth, it would have to hit the ground. What the video is talking about is illustrated here on suncalc.net. The sun rises, heads a little bit south, turns right as it's setting to the north. That works pretty good for his, for the flat earth model. But check this out. Ah, now the sun is turning left as it goes through the sky. That is predicted on the globe Earth, but it doesn't work on the flat Earth. At this part, the video is going to try to explain how the sun goes up and down. Let's let it talk for a while.
Illustrator or a little cartoon from a website called timeanddate.com. It's really funny that they would have a perfect illustration of a sun rising and setting on a flat earth due to perspective. You'll notice that it rises from below the horizon and sets below the horizon. Now you might be saying, well, how's that possible? I can see now you're saying that it rises and lowers due to perspective, but how does it disappear below the horizon? Well, I got a theory about that. Because of the fact that all parallel lines and planes converge at your eye level horizon, this is according to the perspective, I'm not making this up. If in fact, and they do, they converge at your eye level horizon visually, then it makes sense that after that point, they diverge, meaning they then separate. So the sun would continue on a downward track.
Okay. Now, there's so much wrong here that it's hard to know where to start. But we'll start here. Does perspective work as you look upward? Think about it, but don't think too long, because here's the answer. Absolutely it works. There's all kinds of illustrations of perspective as we go, as we're looking upward. So in that picture of the skyscrapers, where does the vanishing point fall on this diagram? Well, it's actually up here. What you need to understand about the laws of perspective is that they don't care about direction. They are willing to work vertically, horizontally. Any direction that you look has a vanishing point. So over here, so you can have a vanishing point over here, or in any direction you look. And not only can it be in any direction, but any distance. Here's a thought experiment. If this guy throws a ball out in this direction, how soon before it disappears? Well, much sooner than the horizon. For a large object, it will have a vanishing point much farther. You could imagine an infinitely large object, and if there was no atmosphere to block, then there would be no vanishing point for that object. The bottom line is that the laws of perspective do not merit you making this drawing. In this drawing, you have two arbitrary vanishing points that are given magical properties. I mean, think about it. He says that the sun can drop below the horizon. In reality, the sun is out here somewhere, maybe farther, and somehow that makes it appear down here. Let's reverse that for a second. Let's say that there was an underground object. Are you seriously telling me that if you could see through the ground, you would see that object up here because of divergence? So you have an object way out here, past his horizon line, way off in the distance, and it should appear up here in the sky. What kind of sense does that make? Doesn't make any kind of sense. Let's go back to this picture here. So let's say that there's a horizon line right here. Would he seriously propose to me that an object far enough away over here should appear over here due to magical perspective divergence? No. It doesn't make sense. As I've shown in some of my other videos, real perspective, not magical perspective, does bring the sun lower as it gets farther, but it is still several degrees above the horizon at the time it should be setting. Okay, at this point, the video is going to argue that the sun is locally illuminating, and this is incompatible with the globe Earth model. I'll let him talk.
Earth and watch it sweep to the right like a bowler bowling it in there for a strike. Okay, now I want you to pay attention to the way the light follows the sun. The sunlight's going to shrink, right, as it follows the locally illuminating sun. Watch this. See it shrinking, following the sun? You do not get that if the sun is 93 million miles away. The entire horizon should fade evenly, just like this supposed shot taken from space of the Earth. You can clearly see the way they depict it. They depict the demarcation between day and night, or light and dark, as a long straight line. And you can see the long straight line moving as one solid piece. That means that the sunset should all fade, the entire horizon should fade evenly. But that's not what we observe, as we will see and as we've seen in the footage so far.
Okay, it's time for a little bit of irony here. Okay, well, here's the irony. What's this? It's a picture of his flat Earth and the sun on it. And what's this? Why, it's an even line going across the flat Earth. In fact, it is reverse curved at this season. Arguably, as it sets over here, there should be more light at the corners of the horizon than at the center. Let's just watch it spin for a second. And what the heck kind of light is this, anyway? That is so bizarre that at one time of year it's shaped like this, and at another time of year, it's shaped like this? What the heck kind of light is that? Doesn't make a darn bit of sense. Just look at that. I want to point it out because, number one, it contradicts what he said about the horizon just a little while ago. And second, they need this bizarre light in order to get the seasons working even remotely correct. In this last section, I will summarize a few different arguments he has. Number one, he shows a video where they're at high altitude and it looks like the sun is larger to him. Second, he shows sunrises where it looks like the sun is coming at us. And finally, he shows sunsets where it looks like the sun is going away from us. I'll let you watch this clip.
For heliocentrism, but this particular one here, shot from above the clouds from this observatory, is the final nail in the coffin. Look at how the sun just shrinks and the light shrinks to nothing. That cannot happen, as I showed you in the when the sun illuminates the entire Earth, which it does from 93 million miles away. It has to. You don't get this isolated look at the sunlight trailing the sun. That's only possible with a small sun, close, not very high, illuminating locally. I mean, if this isn't proof to you, then you gotta take the blinders off.
The answer to all three of these things is put a solar filter on your camera. I know you don't like it, but the sun does overexpose lenses. Let's go see that. Here's a video I made. I turn on the light and suddenly the light in the camera is bigger than the light itself. That's because the lens got overexposed, and it has some ability to adjust, but at first it isn't adjusted, and it gets much bigger than the light itself. I have a second video. I have a second video where I've put a hole in a cardboard. It's a set size, it's not going to change sizes, but I'm going to aim it at the morning sun. Give it a second here. It's already gotten a little bit bigger there. I'm going to get it about right here. That's a lot bigger. Did the hole get bigger? Oh no, it didn't. No, oh whoa! Dang, that lens is overexposed. In this case, the camera doesn't have much ability to compensate, unlike with the light. It just stays overexposed, showing a circle of light bigger than it actually is. And that, my friends, is why you need a solar filter. It's not me trying to fool you. It's just a simple fact of cameras. So go get a solar filter. And if you're paranoid that solar filters were designed by the evil scientists at NASA in order to fool you, here's one you can make at home by yourself. It does tint things blue, but at least you won't overexpose your lens. The whole idea of a solar filter is just cut down the light coming into your lens. And then your camera can cope with it, and then it can show you the real size of the sun. Instead of you thinking that this sun is getting bigger and bigger coming at you, it can show you that no, it's not. Okay, here's an example of someone using a solar filter like they should. On the left, there has been a filter applied, and you can see more like the real size of the sun. And over here, the solar filter has not. And let's just watch them. There are other videos I've seen as well. Some are even better than this, and you'll see the sun very clearly defined, even having sunspots on it. So what do we conclude? There's nothing to this video except more problems. That is a consistent pattern with the dozens of Flat Earth Proofs videos I've watched. There's no proof. There's problems galore. And if you start to recognize that, you can start to recognize at the same time that Flat Earth thinkers are falling short. I'm sorry to say it, but they are. Don't trust them.